Okay, it cut off on me last time. Okay, so we have a negative 5 times a negative 1, which is going to give us a positive 5. So a negative 36, let's do this in our calculators, times 5 is going to give us a negative 180. And that is our answer. Okay, 11. So we're not allowed to have i's in the denominator. So to get rid of an I in the denominator for a monomial, that means one term, we can just multiply by I to the numerator and to the denominator. So what happens when we multiply 7i times I? We get 7i squared. Then what do we do with the I squared? We get 7 times negative 1, which is negative 7. So in our denominator, we have a negative 7. Yay, we got rid of the i's. So now over here, we need to distribute back our I. So we get 3i minus 2i squared. So we've got to deal with that I squared. So we get 3i plus 2, because if we substitute, okay, I'll go back for a second. Minus 2, substitute your negative 1 in there, all over negative 7. So that gives us 3i plus 2 all over negative 7. And remember we said that it's not good math to keep that negative in the denominator. So we're going to multiply the whole thing by a negative 1, which essentially just gets rid of changes all your signs. So we get a negative 3i minus 2 all over 7. But the problem is we're not in standard form. So standard form says that we have to have our real number first, then our imaginary number, all over 7. And then this is standard form and simplified. Okay, 12. So what's different about 12 is that now we have a conjugate. We do not just have a monomial. We have a binomial. So we have to multiply by the conjugate. So we have to multiply by, excuse me, this is not working for me. Okay, 5 plus 2i and 5 plus 2i, because if we multiply it by that in the denominator, we must also multiply it by that in the numerator. Now, we had talked about this when we FOIL this out, that multiplying by two conjugates ends up getting rid of your O and I. So you really only have to multiply the first and the last. But I realized that on your quiz a while ago, that a lot of you think that just because you're multiplying by a conjugate, like up top, then it gets rid of it. So it only gets rid of that O and I if it's a conjugate of each other. So let's just multiply this out so we can see it. So we get 25 plus 10i minus 10i minus 4i squared. So then these middle terms do cancel out, and we can deal with that I squared. So you get 25. Those are gone, and we get minus 4 times negative 1. So you get 25 plus 4, which is equal to 29. So our denominator is going to equal 29. Now we've got to FOIL the numerator. So our numerator would be 6 times 5, which would be 30. 6 times 2i would be 12i. I times 5 would be 5i. And then if we multiplied I times 2i, we would get 2i squared. So combine like terms and deal with your I squared. So we have 30 plus 17i plus 2 times negative 1 all over 29. I'm going to show all my steps here. Some of you guys might be able to skip some steps. But for the video, I'm going to show all of mine. So now we combine like terms. So 29 minus 2 would be 28 plus 17i all over 29. And we can't simplify that, so we are done. Okay, I've done a couple of these all over here, but I will rework them for you guys for the video. Okay, let's see how many we can get done before to cut my video off. Okay, so this is already factored for you. So we just need to set each one of these equal to 0 and then solve. 0 product property, so subtract over 5 to both sides. You get 7x is equal to negative 5. Divide by 7. X is equal to negative 5/7. So then add 3 over. So we get x is equal to negative 5/7. Remember, small is first to the bigger number. Okay, here's 14. So remember on the board, I said first step, is it a GCF? Then ask yourself, is there 2 terms or 3 terms? If there's 2 terms, it's going to be a dots, or it's going to be a sots, and we said sotai to remember the I. And then if it's 3 term, it's either A is equal to 1 or A does not equal 1. If A does not equal 1, you factor like normal with your binomial equals, your binomial times binomial equals 0. And if it does not equal 1, then we use our method that we've been using in class, slide and divide. You can also use grouping if you would rather. Okay, this is what we talked about in class. So let's quickly look at this one. And the first thing is it's not in the correct form. So to get this where it's a squared plus b squared plus c equals 0 means that we need to get that 21 over to the other side. So we would subtract 21 to both sides, so it equals 0. Now we ask ourselves, is there a GCF? Answer is no. How many terms, 2 or 3? Well, hopefully everybody will know it's 3 terms. So now we're over here. Is A equal to 1 or is A not equal to 1? We'll look to see where A is. A is with the x squared. Well, what's with the x squared on our problem? An understood 1. So A equals 1. So now we're just going to factor like we normally do. So we know we have an x and an x. And we're going to ask ourselves, okay, so that's a negative. So that means one's got to be positive, one's got to be negative. So ask yourself, what is going to multiply to 21, but to subtract to give you 4? So multiply to 21, but subtract to give you 4. And hopefully you would say 7 and 3. But you have to ask yourself, which gets what sign? Well, because this is a negative 4, that means your biggest number, your biggest factor, has to have that negative. So 7 would go with a minus, and 3 would go with a positive. And then you would set each one equal to 0. So you get x is equal to negative 3, and x is equal to 7.
Hey guys, pardon the interruption. I just wanted to remind you that girls and guys Bible study are happening today. Boys in room 142 and girls in 144.
So now we write this as x equals negative 3, 7. All right. So let's go to the next one. I'm going to try to do this really quick. Number 15. So again, GCF, there's not one. It's 3 terms. There's no A. A is 1, so we just factor like normal. So factors of 90 that again are going to subtract to give you 1. So hopefully we said 9 and 10. And then the 10 is going to be negative because it takes this sign. Whoops. takes this sign. And so we have x plus 9 equals 0, x minus 10 equals 0. So subtract 9 to both sides and add 10 to both sides. So we get x is equal to negative 9 and 10. Okay, on this one we have to redo. We don't have to redo. We have to subtract 16 to the other side. Now ask yourself, is there a GCF? Hopefully you will say yes. So you factor out a 2. And now we can ask ourselves, this is 3 terms, but a is 1. So we can factor. Factors of 8 that are going to subtract to give us 2 would be 4 and 2. The 4 would be positive, the 2 would be negative. Okay, so what happens for this 2 right here? Can this 2 equal 0? Nope, so we just throw it out. It cannot equal 0. So now we set these equal to 0 and solve for x. So we get x is equal to negative 4. So we subtract over that 4, add over that 2, and our answers are x is equal to negative 4 and 2. Okay. So I'm going to stop right here, and I will finish this later.